anticipated in our previous video. In this lecture, we will describe the typical data analyst responsibilities in a company. First of all, remember that data isn't a valuable asset in itself. It is the insights we can take from it that are the real treasure. And that's precisely what a data analyst is responsible for: gathering and making use of available information to improve an organization's performance. All right. Since we've already agreed on the way we'll treat the terms analysis and analytics and their derivatives, let's focus on the areas a data analyst covers in their daily work: data gathering or data collection, data cleaning, data pre-processing, data visualization, and analysis. Very well. We start off with data gathering or data collection. Whether you've created the data you are working with through surveys, for example, or have been provided with a dataset, being an expert in collecting and working with raw data is crucial. If you compare the entirety of a data analyst's work to the process of cooking pizza, then gathering raw data corresponds to the raw ingredients. Without flour and good quality water, you won't be able to prepare a decent dough. Therefore, once you can confirm that the initial dataset is solid, you can move forward to step number 2, cleaning your data. The process of data cleaning or data cleansing consists in reorganizing your data and improving its quality. For instance, the names of people may have been written all together without separating the first from the last name, or the decimal points in given numeric values could be missing. In cases like these, data cleaning is the stage where you can use programming tools to correct for such errors. At this point, the dough should look like some kind of a ball already, right? But that wouldn't be satisfactory for a cook, let alone a data analyst. We need to punch it, rotate it, and reshape it until we can feel it's ready to be put in the oven. That's the data pre-processing part. Yes, it may require some serious amount of coding, but it is the analytical thinking and statistical methods that are going to be leading that part of the process. Sometimes, this step involves some data manipulation as well, involving techniques such as sorting to reorganize your information into a more presentable format. Now that your dough is ready, it seems that there are plenty of ways to cook a nice pizza. Don't you agree? To be considered a top-notch data analyst, though, you wouldn't stop here. A good visualization speaks more than 1,000 words, so you can proceed by visualizing your data and apply different types of analyses, considering any possible angle. The process of communicating your work through a data visualization is similar to serving the pizza. At that moment, provided that they are hungry, they will eat the pizza and decide whether it is good or bad based on its taste. They'll contemplate the ingredients only if they sense that something's wrong, right? Similarly, a business exec won't focus on your hard pre-processing work. They'll only want to consume the final result, that is, the data visualization. So, with or without using metaphors, remember that data visualization is the stage where you can extract good insights about your business and have a better idea of what can be done to boost future performance. Great! The topics we discussed so far in this lecture concern the essence of the data analyst's job. However, please consider that this doesn't cover everything. As a data analyst, you are not expected to separate yourself from the rest of the world and just code and calculate from dusk till dawn. On the contrary, data analytics is a social activity. New developments inside your company can have an important impact on your work. So, you must be able to understand, adapt, and communicate ideas with ease. Moreover, there are some additional aspects to be considered. We've designed the syllabus in a way that after completing the course, you will be able to respond to all of the following. Know how to deal with a lot of information on your own under time pressure. Have a higher tolerance towards not obtaining the best outcome from the first attempt. Develop solid technical skills, because you need to be able to always come up with a viable alternative if a certain operation cannot be automated for some reason. Be ready to prepare information and visualizations as part of a report through which you can communicate your work to your colleagues and executives. But beyond the technical side, what is perhaps even more important is to be open-minded about the specifics of the industry the given dataset relates to. I say open-minded because, by definition, you're not supposed to be a pro in the relevant domain. That would be an expectation towards a business expert or analyst. In any case, we realize that in a competitive job market, it is curiosity and specialization in different industries that can give a data analyst an edge over other candidates. Such interests eventually lead to flexibility and longevity in the job. Also, this is not theoretical material that you can find in a textbook or a programming language documentation. That's why our training uses real-world examples extensively. I hope that you can now better imagine what a data analyst does, right? To achieve top-notch analysis, or a really tasty pizza, if you wish, we'll need to use a software tool. In our case, that's the Python programming language. And I'm about to share a few important things about it in our next lecture. All you have to do is go to the top bar and click on Leave a Rating. Then, after evaluating our efforts, feel free to share more about your personal experience taking this course. Don't forget to press Save and Continue once you're done. This will mean a lot to us and will help other students know that this course is worth taking. Thank you very much. Having said that, let's get back to Python. There are coding languages and software packages that are best suited for one or a few of the activities a data analyst has to do. Some are great for gathering and collecting data. Others can be really helpful when doing pre-processing. And some tools are great for visualizations. However, integrating several solutions is not always possible. While when you can do that, it is associated with a cost in terms of time and efficiency. Taking into account the responsibilities and requirements of the data analyst job, it would be much easier to go through all the analytical steps with a single software tool. Perhaps there's just one that does the job, one that is rich enough in terms of features and is extremely reliable, one which is what you need to end up with a high-class complete analytic work. This is the Python programming language, or just Python for short. Throughout the course, we will provide detailed technical explanations for all the Python techniques we'll employ. As a general principle, we will use plenty of its built-in capabilities to collect and import data. Also, we will use the pandas library, particularly for the data cleaning part. Next, the impeccable computation abilities of NumPy will help us pre-process information according to best practices. At the last stage of the work of a data analyst, the matplotlib and Seaborn packages will allow us to visualize our work professionally. Naturally, applying these ideas in practice isn't straightforward. The libraries we mentioned interact with the built-in Python capabilities in a specific way. It takes patience and experience to exploit such subtleties optimally. That's why the desire to achieve that level of expertise should act as another main guideline throughout this course. There are also other benefits of using Python. One of them is its large area of applicability. More precisely, if you disregard any technical descriptions and explanations for a minute and consider Python literally as a tool, it is worth noting that it can be used in other programming, analytical, or IT jobs. For instance, data engineers can take advantage of it while improving the performance of your code. Data scientists can use it for building predictive models. Web developers can create websites with it, and so on. My point is that Python will not only satisfy your needs as a data analyst, it will also have synergies when interacting with people from other professions, such as data engineering or data science, for example. To complete our motivation for unquestionably choosing Python, here's a short technical definition and description. Python is an open-source, general-purpose, high-level programming language. Without getting into details, we can briefly touch upon the meaning of these adjectives. Open source means it is free. Python has a large and active scientific community with access to software's source code that contributes to its continuous development and upgrading, depending on the user's needs. This has led to its availability for all major operating systems, Windows, Mac, and Linux. So, here we can conclude that Python is a free cross-platform language that is constantly being updated. General purpose means that it is intended to provide solutions for all types of problems, not just the ones of a data analyst. Also, considering its interoperability with other programming languages, Python can be applied in a broad set of fields such as data analysis, data analytics, data science, machine learning, business intelligence, finance, economics, and so on. High level is a slightly more technical expression. Broadly speaking, computers can run programs written in low-level languages only, also called machine languages. Here, you can imagine code containing ones and zeros. Therefore, High level means employing syntax that is close to human logic, which makes the language much easier to learn and implement. The code you write will be interpreted into a lower level language only later. In other words, it will be transformed into ones and zeros so that the computer can execute the relevant operation. Thus, a high-level language allows the programmer to focus on the task at hand, instead of trying to figure out unreadable lines of code. All right. In conclusion, Python is a very powerful programming language with an intuitive syntax that can cover all parts of the data analyst's job. It can also expand your focus towards the next steps of the analytic process, which is to be predictive and prescriptive about the future performance of a company. If any of the terms we used in this lecture was unclear to you, I'd say, don't worry. Throughout the course, we'll be providing the relevant definitions while constantly assisting you on your way to becoming an independent user of Python and its libraries. But before going through all their fundamentals, we need to have set up the relevant coding environment. That's what we'll deal with in the next section. Thanks for watching. As agreed in our previous lecture, here we'll share with you our vision of how some fundamental business and data-related terms should be understood. We want to define these terms for you from the get-go of the course to ensure you'll have a clear understanding when we use them later on. That said, the first two terms may seem quite clear intuitively, but still, we need to make sure we've provided you with a proper definition explicitly. A business is an ongoing activity operating on a for-profit basis. To put it briefly, you can also say that a business is an organization that exists to make money. Therefore, in all the terms you just heard, the adjective business is there to indicate that the given discipline or field relates to the financial aspect of that activity, as opposed to the one driven by other goals. Not all data analysis is done to reduce costs or increase revenue. For example, a model optimizing traffic congestion in a city cannot be classified as a business model. The term data, on the other hand, means quite simply information gathered for reference. So businesses store as much data as possible to track their activities over time and make inferences that can help them perform better at the moment or in the future. Now that we clarified the meaning of the two terms, business and data, we can go a step further. We can distinguish between two types of data, qualitative and quantitative. Qualitative data comes in the form of text and is descriptive in nature. It does not provide a precise specification, but approximates. In other words, it contains no numbers. Examples are customer feedback or a business case study that describes a particular event in company history. In contrast, the term quantitative data designates numeric data. To elaborate, this is quantifiable information that can be involved in statistical and mathematical computations. When we collect data about the number of units produced by our factory, this is certainly quantitative data. So that's how we define qualitative and quantitative data. Okay, good. Now, let's try to define two processes, analysis and analytics. Dictionaries define analysis as the separation of a whole into smaller, digestible components to be studied individually and examine how they relate to other parts. In a business context, this means breaking down available data into pieces, that is, into its making parts. This allows us to understand it a bit better and to focus on the most important drivers of change. It is also important to realize that any dataset you will work on will always contain past data. What we understand by past data is data about events that have already happened. Therefore, business analysis is the discipline that aims to study a firm's past performance. Right. As you've probably guessed, analytics is forward-looking. In other words, it deals with the future. How does that work? In short, while doing analytics, you take the components obtained through analysis and apply logical and computational reasoning. The idea is to explore patterns in your data that can help you predict future performance. Thus, analytics isn't backward-looking. It studies the future. I believe that now you can easily distinguish between business analysis and business analytics, as well as data analysis and data analytics. Correct? To complete the picture, we can't but at least mention two other disciplines that you have surely heard of. I am referring to business intelligence and data science. You may wonder, what is the relationship the two have with the disciplines we just introduced? Well, for one thing, you should take into consideration that all these fields have been around for a relatively short amount of time, and the primary reason for that is technological advancements. So, loosely speaking, business intelligence, or also BI, studies the past of a company. It is vast and comprises several activities, including business and data analysis. Probably what's most notable about BI is that together with the corresponding analytical methods, it takes full advantage of relational databases. Similarly, data science relies on certain characteristics of business and data analytics. To distinguish it from most other terms, we must mention that it often involves the implementation of machine learning algorithms for the creation of state-of-the-art predictive models. However, you don't always need machine learning tools to make solid forecasts. Sometimes, advanced statistical methods and regression analysis can do the job. But whichever tool you choose, you still have to ensure that your data has been properly prepared in advance. Please bear in mind that some people interpret data science differently. They use the term data science as one comprising all forms of data-related analysis and analytics. According to this point of view, as long as an activity has to do something with data, from business analysis to data analytics and machine learning, it falls under the data science umbrella. All right. By this point, I hope that the industry setting has become clearer. So, I suggest we stop worrying about the accuracy of these definitions and accept the fact that people often misuse terms, or just give them a different meaning. This will allow us to concentrate on the essence of the activities undertaken by the different job roles in the field. With this in mind, there are a couple of aspects you need to focus on to complete our introduction to the world of business and data. We'll present them in our next video. Thank you for watching. All right, excellent. This is where our journey begins. Before we get started with hands-on tasks, I would like us to focus on the big picture. Ideally, in this chapter, we'll figure out who a data analyst is, what they do, and how they create value for an organization. Think about the following words: business, data, analysis, analytics, intelligence, science. Combining these terms gives you the names of several processes and fields that have a growing importance in the corporate world. We can have business analysis, business analytics, and business intelligence. Of course, these relate to business activities. If, on the other hand, we opt for data as the first word, we'd get data analysis, data analytics, and data science. All of these terms are used with increasing popularity. However, there's also significant room for confusion. For example, what is the difference between business and data analytics? And how about data analysis versus data analytics? It isn't very clear, right? In a similar way, we cannot always immediately distinguish between a business analyst and a data analyst. Data-centered professions are relatively new. New because today there is progressively more data than people can make use of. Besides, the speed of making discoveries combined with the rising number of people that join this new data-driven world is leading to the constant advent of new terms and the modification of already existing ones. Therefore, an issue you will surely encounter at the early stages of your journey is to understand the meaning behind such terms. The fact of the matter is that people often use these denominations interchangeably and give them their own meaning. We wanted to be transparent about this potential source of confusion from the start. With that in mind, you should accept the relevant classifications we are about to provide with two constraints. First, although these wouldn't help a beginner set foot in the data analyst profession, people are in their own right to have different interpretations of the most important industry terms. Second, don't forget that in the long run, understanding the essence of a certain activity is way more important than choosing a term to vest it in. If you can accept these limitations, please proceed to the next lecture, where we will simply start our discussion. Hope to see you there, and thank you for watching. Hi, and welcome back. So, now that we've outlined several key terms and processes, we'll continue with the video in which we compare the data analyst role and other data-related jobs. I would like to emphasize that from now on, when we say data, unless specified otherwise, we mean quantitative data. So, under data analysis or analytics, for instance, you can imagine statistical formulas and numeric computations. More precisely, the skills you will need here are related to quantitative disciplines such as mathematics and statistics. as well as technical skills involving the use of programming languages. The term business, on the other hand, as in business analysis or analytics, refers to a business activity focused on an improved economic outcome, using data to make more money by growing revenues or reducing costs. Therefore, if you're a business expert, you are someone who has specific domain knowledge that allows you to understand how a specific economic activity functions. A person can be an expert in the automotive industry, in real estate, optics, and so on. Thus, the key strength of a business person is their ability to understand what creates economic value in an organization and in an industry. A data person, instead, is there to help out where the business people's hands are tied. To be considered a pillar of strength, a data expert should possess quantitative and programming skills that transcend boundaries and are applicable across industries. Consequently, although they have very different profiles, a business and data analyst are in constant contact. As we already said, analysis and analytics, although different, are very strongly related terms. At the end of the day, unless you have conducted your analysis to explain the past, you can't predict the future accurately and precisely. That is to say, you can't really start doing analytics. That's why, and very important to note, the job of a data analyst has evolved to comprise the characteristics of both data analysis and data analytics. Also, when you think of it, a data analyst takes care of both analysis and analytics. So it doesn't really matter whether we will be saying analytic approach or analytical approach. In our next lesson, we'll try to delineate what data analysts do typically. Stay tuned, and thanks for watching.